Alright, today we're going to look at graphing square root and cube root functions, focusing on the square root. So go ahead and pull up Desmos and graph the function square root of x. Remember, the parent function is the most basic form of a graph without any shifts or transformations. Then I'm just going to click 2 points on the screen, 1, 1, and then 1, 2, 3, 4, 1, 2 is another point, and I'll collect those. Or connect those. Remember, I'm not going to have you graphing by hand, so just graph it in Desmos to see the general shape. Alright, so the endpoint is always going to be this point right here. Notice our parent function of a square root is a curve in quadrant 1. So our endpoint is 0, 0. The domain is looking at the x-axis. So the x-axis, notice it's only in quadrant 1. So it only goes to the right, to the positive axis. So your domain is going to be 0 with a bracket, since that point is on the graph, to positive infinity with a parenthesis. Your range, and you always do left to right for the domain, your range is the y-axis bottom to top. So the bottom of the graph, the lowest point is at 0 on the y, and then it will keep extending up and up to positive infinity. So also 0 to positive infinity on the y. And actually, we'll probably just skip the cube root. Well, let's just go ahead and graph it. This is not even in our standards, but the cube root of x is an S shape cutting through, that wasn't very good, but cutting through quadrants 1 and 3. Should be more curved, like that. So an S shape cutting through quadrants 1 and 3, and the turning point is at 0, 0, and the domain is all real numbers, and the range is all real numbers, because it'll keep going out on the x, and then gradually up and down on the y. It'll take into account all numbers for the domain and range. Alright, so for this, here's our transformations that we're looking at. They are actually the exact same as the quadratics that we did in Unit 1. So the h is going to be the horizontal shift. If it's plus, it actually shifts it left, and if it's minus, it shifts it right. That's whatever's inside the function. That was just like if we had y equals x minus 2 squared, you shift right 2. It's the same idea here. K is the vertical shift. If it's plus, it shifts up, and if it's minus on the end, it shifts the graph down. The h and the k is going to be that end point or the turning point, just like it was the vertex. If a is negative, it's reflected across the x-axis. And then if a is greater than 1, let's say 5, that's going to be a vertical stretch. So it'll stretch your graph vertically. Like go further up, really. And then if a is a fraction, it'll be a vertical compression. Alright, describe the transformations. If you need to graph these in Desmos, that should be helpful. Remember, you're always comparing it to that parent function we graphed up top. So this one will shift right 7. Opposite of what we would think inside the function or underneath the radical, and then it will shift up 2. Same idea for the cubic function. Same transformations for all functions, just the shape of the graph changes. So the negative is still the reflection, and then the x plus 3 inside the function actually shifts it left 3. So you go ahead and try numbers 2 and 4 and make sure you check the answer key on those. Sometimes you'll be given a description and then have to write the equation instead of the opposite like we just did. So here we have a square root function, so that's going to be y equals square root of x. Remember, you can put the index of 2 if you'd like, but you don't have to. It is shifted 7 units left. Okay. So that's actually x plus 7 inside the function as your left to right shift. Then 1 unit down, so I'm going to put a minus 1 on the end, and then it is reflected across the x-axis, which gives me a negative out front. So let's write the equation. So there you go. We'll skip number 6. Alright, so I'm just going to do one of these for you. So let's jump down to number 8. And I like to start by writing the transformation. So for this one, we're shifting right 1 and down 4. Again, I recommend graphing this in Desmos to get those specific points. And so when I do that in Desmos, I see 1, -4. And again, that's because I'm shifting right 1 down 4. That's actually your end point or your turning point. 1, -4. And then we had +2, -3, and then it shoots off to the right. So here's our square root function. Okay, so domain, left to right, what's the furthest left point? That's 1. And then it'll shoot to positive infinity on the x. Range is bottom to top on the y. Range is your y-axis. What's your lowest y value? That's -4, and then it'll keep going up and up to the positive y's. It's not in the positives right now, but if I kept extending it and zooming out, it'd be way up top. So this one's going to be -4 to positive infinity. So we've looked at domain and range before, but this time your domain's not all real numbers like it was for the square root functions. Okay, so your end behaviors, I always like to do the left end first. I think my answer key online does the opposite, but that's okay. The end behavior of the left end is just going to be at +1, -4. The right end, if I kept extending it, what quadrant would it be in? It'd be in quadrant 1, so it'd be positive, positive. Remember, you're using the signs of the quadrant. Okay, so for increasing and decreasing interval, there's no decreasing interval. I guess unless that there was a negative out front of the, I keep saying quadratic because we did that so much, but if there was a negative out front of the square root function, you'd have a reflection and it would be a decreasing interval, and there would be no increasing. So your increasing interval here, remember we're looking at the x-axis for this, is going to be at 1 to positive infinity. And you always use parentheses for these. That's something the answer key does not do, so make a note of that. Always use parentheses, because technically when you use a parenthesis, it indicates that point's not included in whatever you're listing. Here we're listing the increasing interval. We cannot say at point 1 it's increasing. That's not possible, so you use a parenthesis. Infinities, you always use a parenthesis. Okay, go ahead and try number 7 and 9 on this sheet and check the answer key posted. Thanks.